you've been in Common Core long enough to know this, I think, but it's easy enough to lose sight of what the expectations are versus what you do in class, because in class it's like, all right, let's learn the skill, let's apply the skill, let's do something with that skill, basically. But what they want is for you, also one of the buzz phrases is to critique the reasoning of others. Okay? That's where the group work comes from, and that's where problems like this come from. So do we do this for fun in class? No. No, I'd rather have you critique each other's work, because I think that's infinitely more entertaining. But these problems tend to work their way onto the Regents exam, right? Because it's like, I mean, you'd love for it to be just solve for X, but oftentimes it's Charlie did all this work, Christina did this work. Who's right? Who's wrong? Who, or why, you know, justify your reasoning. The worst kind of question, I think, from a student standpoint is, all right, they're both right some of the time. Tell under what circumstances the first student's right and under what circumstances the second student's right. So they really try to kind of get you to think. I think it ends up being more frustrating than anything else, but it is something that you need to become more and more proficient with, because as the math gets harder, it gets more difficult to see where the mistakes are, you know? So, you know, in Unit 1, it was like, oh, it distributed wrong, or added or subtracted wrong. Here, now, it's like you actually have to know something about what you're doing, right? So it can be tricky. So we go through the progression. The first step in the process should be cross multiplication. All right. So if I'm cross multiplying, my stylus has disappeared.
What about the undefined number?
I'll get to that in a minute. I will use a backup stylus. Fortunately, I have a few. So we have to go by what we see on paper, right? Because when I'm grading your work, I mean, that thought is going to go through my mind. What about the excluded values? Well, yeah, I have to kind of keep that in mind, and then at the end, ask myself, was it accounted for in some way? All right. So far, no, but we'll see if that happens to be the case later on. So cross multiplication would tell us to multiply the x squared minus 9 by the 1. So that would give us this guy. That looks good. The 3 by the x minus 3. That's the same as 3x minus 9 if distributed properly, right? So that seems reasonable enough. So then the question would be, all right, what is this nonsense over here? Yeah, but like, where did it come from? Just magic? Or was this individual trying to do something?
They did actually.
They did actually do something. The thing is, maybe that person should have drawn a line here. I mean, it's a small mistake, but this is an operation. It looks like they were trying to subtract 3x from both sides and add 9 to both sides. So maybe a little bit more work could have been shown. It is possible that this is the only mistake in the process. It's not really a mistake, it's just an error by omission, but we'll see if it pans out. X squared minus 3x, that's there. Negative 9 plus 9 goes to 0, so far so good. Now you get to x squared minus 3x. It's quadratic. You've got to be able to identify something as being, at this point, I only need you to know the difference between linear and quadratic. Linear is power of 1, quadratic is power of 2. If your expression or equation has a power of 2 in it, you're looking at something that is quadratic. Right? So once you identify it as quadratic, you start thinking, what are my techniques? Get everything over to the same side, then factor. Right? What is the most basic form of factor? GCF. Did that happen here?
Yeah.
Yeah, we pulled out an x, or this person pulled out an x. And we got x times x minus 3. So then the next step in the process would be to make that t-chart, set the first factor equal to 0, set the second factor equal to 0, and solve. I don't see anything wrong with that. So you might look at this and say, yeah, this is perfectly fine. However, this individual did not take into account excluded values, as we were talking about before. So there's one of two ways to handle this. I mentioned this yesterday. One way is a little bit more explicit, meaning you're showing all the steps. The other way is really just kind of eyeballing it. You're asking yourself, is 0 a good number or a bad number? How would we know if 0 was a good number or a bad number? That's the important ingredient.
You see if it goes to 0.
See if it gives a 0 in the bottom of the fraction. If I plug a 0 in for x in each of those denominators, do I get 0 anywhere?
Yeah.
No. If I plug in a 0 here, it becomes -9. If I plug in a 0 here, it becomes -3. So that's perfectly fine. 0 is okay. So that's a good solution. I think standard yellow highlighter is what I'll go with here. Or at least it comes up on my screen as yellow highlighter. Now, what about the 3?
No.
No, because if I put it in the x minus 3, 3 minus 3 gives you 0. If I put it in the x squared minus 9, 9 minus 9 gives you 0. All right, so 3 is a bad number. Whatever, I'll just look at it. So you only have one solution. They kept a solution that was bad. All right, it's going to bother me. All right. So the method that we talked about yesterday is a good method if it's a free response question, if you have to show all your work. If it's a multiple choice question, I don't know that you want to spend the time taking each of your denominators and setting them equal to 0. Because if you do, that's time that you could be using to do other problems. All right? But if it's a free response question, you would take the x squared minus 9 and set it equal to 0. And then you would also set the x minus 3 equal to 0. And then often, many cases I'll say, I won't say oftentimes, but many cases, you'll end up getting an overlap in terms of the solutions. X squared minus 9 factors to what? And what? X minus 3x plus 3. All right? One of which, the factors, so you have an x minus 3 factor, corresponds with the x minus 3 that's in the other denominator. So that tells me I don't have to worry about this. So I could just set these equal to 0 and get x equals 3 and x equals -3. So these are my excluded values. I'll get rid of the colon, I'll just draw an arrow. The bad values. All right, so if I do this algebra, if I perform these calculations, I'll determine what the bad numbers are. So that when I go through the actual solution, I can make a determination of whether or not all of those results need to be there. Right, so when I compare these answers with what was over here, I see that the 3 is a bad value, it goes away. All right, but that's not something I would do for a multiple choice question because I don't need to show any work. I just need the answer. That's something I would do for a free response question. And part of the challenge, especially when working towards a Regents, is knowing the difference. So I show you multiple methods. Do we have to do this all the time? I mean, it's a question that's not always relevant because it's like, well, yes and no. If it's a multiple choice question, no. If it's a free response question, yeah. So just always think of it that way.
How come you choose x squared minus 9 and not x minus 3?
It wasn't a choice. I went with both of them. But then once we factored this and I saw one of the factors was x minus 3, I was like, forget that. I don't need to do that. It's a waste of time. Okay. So, applications. Sometimes we reject a solution because it's a bad number mathematically. It gives us an undefined or imaginary result. But sometimes we reject a solution because it doesn't fit with the context of the situation. If it says something like find 2 positive integers and you come up with a negative value, toss the negative. If it says come up with 2 negative odd integers and you come up with a positive even integer, toss the positive even integer. It's all based on context, right? So that's coming into play here. Length of a rectangle, put the emphasis on the wrong syllable. The length of a rectangle is 5 inches more than twice a number. the width is 4 inches less than the same number. All right, so the complete unknown here would be the number or a number. So let x equal a number. And we already know that if you don't include a let statement for any of these application questions, you're throwing away 3 points. Because you also, you get a point just for including a let statement. Think of it that way. I'm not taking one away, but that's the same as giving you a point. If you do not include a definition of your variables, you're going to lose credit. And you've all experienced this. Well, not all of you, but in many cases have experienced this. All right. The perimeter of the rectangle is 44 inches. Sketch a diagram of the situation. So it's telling you explicitly to sketch a diagram. All right, so it's rectangular, so that's nice. And find the unknown number. All right. The width is 4 inches less than the same number. All right, so x minus 4 is equal to the width. Now that a number, because it's saying, we have this complete unknown that we're calling x, that's a number. The length of it is 5 more than that. Okay, so I probably should have written that first. So x plus 5 would be your length. This particular question.
Twice. It's 2x.
Oh, twice?
Yeah.
Ah. Indeed it is.
Typo?
Negatory on that. No, it's got to be typed to be a typo. Oh, that's not actually true. If I post an answer key or something like that and you find a mistake, I'll also take that. So, yeah, twice a number added to 5 is going to give us a length. All right. Very easy to lose credit on a question like this because eventually we're going to have to find the unknown number, but if they ask us for the dimensions, then they're asking us for these results. So sometimes x does not mark the spot. Sometimes we have to do more work. All right. So length and width we have represented algebraically. The length is 2x plus 5. The width is x minus 4. And the perimeter is 44. All right, so it's going to give us a linear situation because all you have to do is add up the 4 sides and set it equal to the perimeter. So 2, 4, 6x, 5, 10, minus 8, so plus 2 is equal to 44. All right, so knock off the 2 from both sides. You get 6x is equal to 42. X would be equal to 7. All right, so in this case, they were asking us just to find the unknown number. So x is all we need. But if they said find the length, I'd have to plug the 7 in to 2x plus 5. If they said find the width, I'd have to plug the 7 into x minus 4. All right. All right, so then they ask us for or at least something related to the area. The area of the rectangle is 15 square inches. All right, so I'll draw the diagram again, even though they don't ask us to. But the area is equal to 15. The length is 2x plus 5. And the width is x minus 4. All right, area is length times width. So I would just be looking for the product of x minus 4 You have 2x plus 5. That should be equal to 15. All right, so that's, again, length. Oh, well, in this case, I did the width first, but it doesn't matter because it's commutative. So the two dimensions multiplied to give us the area. All right. This is related to the quadratic topic because we actually have to multiply those two dimensions. So when we multiply, we're using double distributing. So 2x squared plus 5x minus 8x, so negative 3x minus 20 equals 15. 2x squared minus 3x minus 35 equals 0. The reason I knew to do that, I'm subtracting the 15 from both sides, is because it's quadratic. If it's quadratic, you have to have everything on the same side of the equation. Quadratic, again, means the highest power in your equation is 2. All right? So it's a polynomial where the highest power is equal to 2. Now we just have to come up with the factors. So you may know it, you may not know it. I'm going to assume that it's a leading coefficient other than 1, so maybe you want to do the x chart. If that's the case, you're going to put a negative 70 up top, product of A and C, and negative 3 on the bottom, and figure out what the factors would be from there. You may want to go to the calculator for this. But, I hopefully, anyway, you shouldn't need to, because the first thing that pops into your mind should get you there. Give me two numbers that multiply to 70. 10 and 7. So we'll start with that.
I didn't think of that.
Negative 10 and positive 7. So 2x squared minus 10x plus 7x minus 35 equals 0. Split it. And again, that's assuming that you're just not ready to try the trial and error approach. It takes a while for some of us. All right. And, you're going to have this feeling, I think. Well, I don't want to speak for your feelings, I guess, but it seems like we're undoing everything that we just did. And it seems like this can't possibly be the right way to go. But if you think about it, yeah, we distributed and now we're factoring. And factoring is undoing distributing. But once we distributed, we incorporated the 15 in. So now we're factoring a new equation or a new expression on the left-hand side. So what we're going to get is a different set of unique factors that are going to allow us to make the determination of what the value of x is. All right. So once we do that, our 2x plus 7 and the x minus 5, you could set each of your factors equal to 0 and solve, but then the context of the situation might determine whether you're going to toss one of the solutions. So the first solution, I subtract the 7, divide by 2. I get x equals what? Negative 7 over 2. All right, and the other one, I add 5, so you get x equals 5. All right, so go back to the setup of the problem here. The preamble is wonderful information, but it's really this stuff here, where we define the width as x minus 4, and the length is 2x plus 5. All right, so it's at this point that we can determine that the negative 7 over 2 is bad, but not because it's negative in and of itself. All right, this one's going to go, and it's bad because it makes the width negative. So this is the only one I want. I want the 5. Now, this is I can't emphasize how important this is. This is so important because there is a segment of the population, segment of this class that's going to walk out of this room today and say, we crossed that off because it was negative. The message will have been completely lost. We did not cross this off because it's negative. We crossed it off because if I were to replace x in one of these two expressions, you would get a negative dimension. If this said x plus 4, negative 7/2 would have been perfectly fine because I would have got a positive width and a positive length. Actually, I would not have gotten a positive length. So I'd have to choose a different set of factors. But it is entirely possible that I can take a negative x value and plug it into the given expressions and come up with positive relationships. If that happens, then we're good. The reason why they need to be positive is because, I mean, just think about a ruler. You don't see any negative numbers on there, right? So we're talking about absolute distances. We're not talking about direction. So there is a time and place for negative distances. It just means, like, if I were to say something is 5 miles, that's 5 miles in the forward direction. Negative 5 miles would be 5 miles backwards, right? So there are some contexts that allow for negative values of x, right? And you have to be careful about what those contexts are. So you don't just dismiss it because it's negative, right? I'm trying to emphasize this as much as possible because there's always a trick question. And it's not from me, from the Regents people. They always do something like that, where they want the right answer to be the negative one, so they make it so that the positive one fails and the negative one is the correct one, even for geometry situations. All right. So I'm kind of imploring you to really think about this. Don't just toss it because it's negative. I mean, it's something simple like find 2 consecutive negative integers. You know, why would you toss the negative? That's exactly what you're looking for, right? So really think about what the question's asking you, right? But you should also be prepared. They don't ask it here, but be prepared to find the actual dimensions. Dimensions just mean length and width for a two-dimensional situation, rectangle. For like a cube or something like that, it's length, width, and height. All right. So all the lengths of the sides that go into whatever figure you're dealing with. All right. So it can get tricky, but only because of the fine details, not because of the overall concept. Overall concept is factor, set each factor equal to 0 and solve. Find excluded values. Same stuff we've been doing. Now you're adding in the little tiny details that if you struggle on this, I mean, it's what I'm going to say to your parents when they ask. They studied so much for the test, the quiz, the Regents exam. I don't understand why they went wrong. And I'll say the same thing that I always say. It's because they have a good sense of the overall picture. It's the little tiny details that they're losing track of. All right, so take time considering these word problems. Don't just rush through them. All right, that's been the theme, at least for the last marking period, and it's going to continue to be the